Optimization of material formulation and process parameters in canna-ethylene starch-based biofilm synthesis. Biofilm has begun to develop both in material and technological aspect. This condition was a solution to of petroleum-based plastic waste, one of which is styrofoam. Even though styrofoam has a high strength, lower absorption, and low economic value, but the impact on the environment was consideration to minimize the use of this material. The raw material used in manufacture of biofilm consists main ingredient and additives. Main ingredient that often used is starch and fiber. It's because the renewability, abundant availability, and cheap price. The characteristic of starch is hydrophilic, which is as easily absorbs the water, and the fiber can increase flexibility and mechanical properties. And the characteristic is hydrophobic, it absorbs less water. Based on several studies, starch plus 20% fiber used to make a biofilm. Modified starch with addition of substances such as plasticizer, polymers, fibers, and several other additives, and different molding temperatures in range of 130 till 170 Celsius degree. Using this right temperature effectiveness of molding, energy efficiency use, and this study aims to optimize the product formulation and printing process temperature. Formula of cornstarch and rice straw powder we use is 5 formula, and the process is mixing dry ingredients, forming a dough with addition of glycerol, water, and PVA liquid, and mixed dough was molded using self-developed thermopressing machine. This process used a printing temperature variation 130, 150, and 170 Celsius degree with duration variation 5 till 15 minutes. The figure is thermopressing machine. We use 4 tests in this research. Is water absorption, density test, tensile strength test, and biodegradation test. The result is the first appearance. This is the appearance of sample of biofilm using temperature 170 Celsius degree. Getting red is containing higher starch. More fiber has an impact on the resulting biofilm darker color. More starch has an impact on the resulting biofilm lighter color. The resulting biofilm has a uniform color. It caused dough wasn't mixed homogeneously, and temperature has no significant effect on color parameters. It because pressing time used to feed the temperature. Product density. The density of biofilm produced in this study ranged from 0.38 till 0.59 gram per centimeter cubic, and if we comparing with the styrofoam, the density was higher, but from the other research is comparable and the lower density. Biofilm with a higher fiber proportion make a higher density. It because the fiber is hydrophobic and may inhibit expansion, and biofilm product will be denser and result in high density. Based on the same analysis performed with magnification of 100 times, is mixing of material wasn't homogeneous in all treatments. We can use it. We can see it. Fiber and starch were not fused and excess expansion. The size of the inhomogeneous porosity was caused by the inhomogeneous distribution on the material. Product water absorption. The water absorption produced in the study ranged from 15.48% till 29.2%. If we compare with the other researches, this water absorption is lower from the others, but higher from the one of the research. Modified sago starch with pitosan. Starch has hydrophilic properties, can easily absorb water, can accelerate expansion and form cavities. More starch, gelatinization process will be higher and faster expansion. Increased porosity and cavities, and easily filled by water when biofilm was dipped in the water. In addition, the use of biofilm packaging requires tensile strength testing to determine the strength of biofilm. Tensile strength of each sample was different and fluctuates. High temperature didn't affect the tensile strength because the duration of time used adjusts to temperature used. Tensile strength material can cause by composition of material, high fiber, make a lower expansion, make a biofilm didn't have enough cavities, and make it easier to break or bend. The product biodegradability. The biodegradation produced in the study has a range of 54.88% and till 92.67%. And the other research, biofilm based on tapioca and cellulose cassava peel has perfect biodegradability after approximately 5 weeks using composting method. And we can see the temperature is not significantly different, but the formulation has a significantly effect on the result. And this is the figure of biodegradability of sample before and after. The conclusion. The optimization of the formulation didn't significantly affect the quality of biofilm produced. The optimization of the synthesis process parameter has no significant effect on quality of biofilm produced, but can influence on energy and production scale-up process. Density was comparable to several previous studies. Biodegradation rate has a better, but water absorption capacity was relatively low, and so on the tensile strength. Thank you.